All right, in this optimization question, we're going to be looking at a piece of wire. So with this question, you have a piece of wire is given to you. It's 100 centimeters long. And what you want to do in this question is you want to cut this into two pieces. So you're taking the wire, chopping it into two pieces. You don't know where. That's what we want to find out. But the one piece you're doing, you're going to make a square out of it. And the second piece, you're going to go ahead and make a circle out of this. And the goal of this, like where you want to cut this wire to create these two shapes, is you want to maximize the total area of both of those shapes there. So to start us off here, you've got yourself a wire, piece of wire. And like I said, we don't know exactly where we want to cut that length. That's what we have to find. I'm going to let that be X. And since the whole wire has a total length of 100, the leftover length must be 100 minus X, right? Like 100 minus whatever this length is. If this is 25, this will be 75. If this is 50, this will be 50. That'll give me my leftover length here. So what I'm doing is my first shape I'm creating is a square. So we're going to create a square out of the first shape here. And my second shape is going to be a circle. And these are our two shapes. So I'm looking to maximize the area of these two shapes here. So of these two shapes, I want to maximize the area of them. Okay, so now that we have something to work with here, I'm going to first calculate the area of my square. So the area of my square here is fairly easy to calculate. The total length, the perimeter, I should say, of this square has a perimeter of X. So again, the distance all the way around, because the length I've cut this at, I'm assuming is X. Distance all the way around is X, so therefore each one of these sides must be X over 4 if this is in fact a square. So the area of my square is going to be X over 4 quantity squared. Now with the circle, we have that the area of a circle, as we know, is pi r squared. This is what I want to calculate. So area of a circle is pi r squared. I need to find the radius here, but what I do have is I actually have the circumference. I know the distance from here to here is 100 minus X. That would be exactly the distance around this circle. So I know that 100 minus X is equal to the circumference of a circle, which we know is 2 pi r. So therefore the radius of this circle must be 100 minus X over 2 pi. So therefore the area of a circle is pi times my radius squared. And now I have the area of a circle. So what I'm looking to do here is calculate the total area. So my total area here is the sum of both of these areas here. So one area is X over 4 squared plus pi times 100 minus X over 2 pi squared. And that represents my total area that I'm looking to maximize here. So again, we'll make this a function of X here. I want to go ahead and let's clean this up a bit. So this will be X squared over 16 plus pi. I'll leave the 100 minus X not expanded out, but I'll expand out the bottom, gives me 4 pi squared. So therefore, the total surface area of these two shapes here is going to be X squared over 16 plus 100 minus X quantity squared over 4 pi. So therefore, if I go ahead and calculate my derivative, this will be t prime at X is going to be what? You're going to get, drop down that 2 and simplify, you get X over 8. Plus again, if I drop down that 2, the 4 pi in the bottom will become 2 pi, and then the chain rule kicks in and you get derivative of the inside is going to be equal to -1. So I have t prime at X is the following. So now what I'm looking to do here is I want to find the critical points or point of this function here. So I'm going to have to set this equal to 0. So therefore we have, with this question, is 0 is going to equal X over 8 minus 100 minus X over 2 pi. So solving for this here, I'm going to go ahead and multiply across by 8 pi, giving me 0 equals, pi x minus 4 times 100 minus x, in which case I get 0 is pi x minus 400 plus 4x, and I get 400 is pi x plus 4x, and therefore I can factor out the x, and x is 400 over pi plus 4. If I calculate this, 400 over pi plus 4 is 56.01. So that represents the where I'm going to be cutting this rope at, this wire at, is going to be, x is going to be 56.01. This is not necessarily my answer. This is just my critical point. This is one of the values here. So I get a single critical point at 56.01. We have to check the endpoints of this situation as well. So one option is that x is 0. So if x is 0, that'll mean that this entire expression is just going to be one big circle. And the other side of the idea is x is 100, in which case this entire length we're going to change into one big square. So those are the two endpoints of this word problem here. So let's take a look here. I'm going to go ahead and take my function t at x, the original total surface area function. I'm going to grab this and I'm going to evaluate this at our critical point and both of our endpoints. The largest would be our answer. So in this case here, we're going to evaluate this at t at 0 for one of our endpoints. T at 0 is going to give me pi times 100 squared over 4 pi. And so this will be pi times 100 squared over 4 pi squared. And if I go ahead and calculate this, I end up getting approximately 795.77 square centimeters. The first endpoint was we were making x is going to be 0 here, so it's one big circle. And the next idea is the opposite end. We're going to get rid of this circle, make one big square out of this. This will end up being 100 squared over 16, which is equal to 625 square centimeters. And lastly, we have our critical point here, 56.01. And if I evaluate this at our value here, we end up getting 350.69 square centimeters. So of these options here, we can see that the maximum area, which was the goal, the initial goal, ends up being one of the endpoints. So it ends up being max area happens when you have all circle. So you're just making one big circle out of it. That would have been the easiest option, and that would have given you the maximum area of the two shapes here. All right, this is a wire question. There's all sorts of variations on this question. They namely come with the difference of shapes. Sometimes it's be equilateral triangles, rectangles, shapes like that. All right, thank you.